It was a bit weird because I was trying to do calculations with the phone in my hand, but basically, okay, 393, okay, and so what I've done is I basically created this column, which is the difference of the two other columns, yeah, and so let me just make it big. There we go. So you can see here that I'm basically doing the the maths calculation that should be done in the software. Let me just make it into a 3 decimals. Okay, and then at least it shows it correctly. There you go, it's tabulated correctly now. Okay, so now we have it, right? And it's 3.9 ish. Okay, obviously. Oh wow, why is that saying 2? Oh right, so what happened there, the reason why it's like that is because I was actually reconnecting it so that I could see the voltage change. So those don't actually, they're not part of it, so let's take those out as well, because they're not part of this calculation. Delete those. There we go. That's gone. Yeah, it's gone. Right, and what I've done in the graph is I've altered it. Let me put the full minimum. Okay, so you can see in the graph, basically you can see obviously where I turned on the power pack, right? Now they're at two different voltages. They're obviously at two different voltages, and it is reasonably consistent as to where it is. And if I was to average those, right, then you'd see really clear lines. Okay, I can actually do it in this spreadsheet app, but I'm not going to. So you can see there, obviously I turned the power pack on then, right? It's pretty obvious, isn't it? And then we've got, let me put full width on, yeah, okay. Get up, right. So you can see, there I turned the power, you know, and this one gets a bit noisy, but part of the reason why this has got noisy is because it's a difference of two signals which both are noisy, so you're amplifying the noise. So you kind of can't see the voltage change in that. Okay. If I was to average it, then you might get it. Especially if I was to base that on the average, then it would be a bit more obvious. Which probably would do actually. So, yeah. So you can see this charge being added. It's obviously on 7.6 right now. Okay. And it's being charged. It's charged at 1 amp. These are 40 amp hour, I believe, cells. So to go from flat to full at 1 amps would be 40 hours in theory. In practice, you get between you should get between 20 and 80%. In order to maintain a healthy cell, it has to be between 20. That's 60% of the cell. Okay, because these are lithium ion cells. They're not lefipos. Lefipos you can have more, but these ones you really should restrict it 20-80. Okay, specifically 80, so you don't go to the full, because then they start getting the dendrites. And then you get cooking. So that's what this is doing, and currently I've actually set it that the voltage supply, the constant voltage is set to 8 volts, 4 volts a cell, right? So there's 2 volt margin basically. Okay, now this one is already on 3.9, right? This one is on nearly 3.4. Okay, so we got a difference between them already. You see, so they're imbalanced, which is good because this is supposed to be something that I'm actually creating which will balance cells. So we have actually got a good situation here to create our cell balancing algorithm. We need the hardware to do it first because it needs to be able to redistribute the power, right? Now what I can actually do in order to fake it, because ultimately this will be connected to a larger power pack, it wouldn't be just the 8 volts of the pack itself. So I can actually just simply use like a second power pack that's set to 8 volts, right? And then use that to actually balance the cells, and I can get it to just simply do whichever one it wants. Right, now I've only got this one available right now. All of the power packs that I have are actually in use. What I might do in order to just make it work, and it doesn't have to be an accurate one, I can use like a power brick or something, I guess. You know, just some 12 volt power pack would be fine, I think, and I've got those power bricks, so I can use a 12 volt power pack or something like that, which I can connect in here, and then basically, because this will connect to the mains, it'll be isolated, so that means I can actually make it so that it will balance the cells. So it will work in that theory, but what it won't do, of course, is draw the power from the cell from the pack in order to charge a cell. So I don't know. The only way I can think of doing that, right, is in actual fact to get 4 of these, which then brings it up to 12 volts. Right, I'm thinking so I don't have to manufacture something. I can get this up to 12 volts, and then that will actually work through a DC to AC converter, or you can get 12 volt. I think you can get 12 volt flyback converters. No, they don't. They just make buck converters, don't they? It needs an isolated buck in order to do it. I guess what I can do is that I actually can get hold of isolated DC-DC units. They're not cheap, but I can get them. I might even have one, which you use them for powering gate control circuits. I can use it for this. Yes, I can. Yes, I can. So what I might do is actually dig out one of those, and they can. The ones I have are like 2 amps or something. They're actually quite considerable, and so I can use that to power this. Yeah, because all I need is the isolation, don't I? It needs to draw the power from here, okay, to redistribute it, and it should do it. The better condition is to do it when actually you don't have any power supplied either, because then you really are balancing them. This one might be robbing some power from the power supply, yeah? But if I actually disconnect it and then actually try to balance it just on its own, then we actually see the effect. So that would be a good one, yeah, okay. Yeah, I have, in fact, they're down here somewhere. I have them. I got something there, I don't know. So I'm going to actually dig something out. There you go, look. See these things? Right? Oh, it's a bit of a mess. Let me pull it off. Because it's just pushed onto the board. I can always put it back. Yeah, this. Oh, man. Right. There you go. Look at that. Okay. Right. Put light on. Right. This is what I can use for now. So the input is... Oh, let's get that off. And then we got the spec. Oh yeah, that'll do. So, what's it saying? The input is 9 to 18, is that right? Yeah. 9 to 18... Oh, right, we don't have 9 volts. It's a bit too low. Yeah, and the output will be... I mean, the output's fine. It's a 12 watt one. Because it's got 15 volts DC, and it's oh wait, it might not be actually 12. Yeah, that's a bit of a shame, that. If I got a boost converter, it'll work, and I have those. Boost converter. This is on 7.5. What's the voltage? 9. If I got another one, get a third one, then that will bring it up to 3/4. They're 12 volts, aren't they? I think most of these, the ones that I have, most of these I've got, they're actually rated for a 12 volt input. Yeah. And they require a certain voltage input because the circuit inside needs a power supply of a certain amount in order to do it. Yeah. Because essentially inside there is a little transformer. And then you got basically a DC to AC circuit in there. It's just a very simple oscillator, which then does a transformer, and then on the outside you've got a bridge rectifier and smoother and then regulator, and that's essentially what's inside there. And that's what I'd have to make. And I could make it, I guess. I can make a 1-to-1 that would work on that as well. Yeah, but that's too much engineering. I want to be able to do this stuff without that. It's a bit of a shame. And I don't have another one of these that's in good condition. I've got ones that are blebbed out and stuff, but I mean, I guess that would work, wouldn't it? Alright. Thinking loud now, so I guess you don't care.